while we finish up these notes, you're going to have to think. The only way you're going to form those dendrites so that your brain starts thinking in this way is if you actually do it. If you let me do all the thinking or you let your peers do all the thinking, your brain will not form those dendrites and you will not be able to think in this way. This comes from you actually putting forth the work. So we're going to start with number 6 because we skipped that yesterday. That one was a lot like number 5. And I'm going to stop talking for a second. I want you to think or try what you think maybe you could do here. Our goal, remember, is to get this down to one trigonometric ratio or number. That's our goal. And you should be using pencil because you might make a mistake. And then we'll go over it. So try number 6. Oh, you have it. All right, Tim, what'd you do? Foil. Factoring, it was already in factored form. So you multiplied them back together by foiling. And then what happens? What do you mean on the other side? Okay. So we don't have an equal sign, so there's not a side. So what I have here is I have secant squared minus 1, which kind of sounds like maybe one of our identities, those Pythagorean identities. So you flip your page over and you were looking for secant squared x minus 1. So here's secant squared x. And if I make it minus 1, if I move that minus 1 over, what's it going to equal? Okay, so it's squared. So this is tangent squared x. And it's down to one trigonometric ratio, we're good. So the next one we haven't done is number 9. Number 9 has 2 fractions and they're being subtracted. So remember, we're trying to get it down to one thing, so eventually we're going to have to subtract these fractions. And I might not want to do it as is, because they don't have the same denominator. So maybe there's something else we can do to make them easier. Start looking at your identities, start thinking for yourself, maybe put something on the paper. You have to try something. If it's wrong, you can erase it. Try something. Yeah, I'm just tripping around. Do you have all these memorized? You have all these identities memorized? Then look at them. And try something. Switch something out. Flip that on your paper. Switch something out. So, if this is squared, then go. They're looking around to see who has put something on the paper. Even if it's wrong, I'm looking for something on the paper, so you cannot cancel it. We cannot cancel over a subtraction problem. If that was multiplication, it'd be fine, but not over subtraction. Gotta switch something. It'd be the wrong thing, but try something. Don't just sit here, taking up space. Try something. You try something. Try something. Alright, so I've walked around and seen lots of different things. And I've got news for you. There's more than one way to do these. There is more than one way to do these questions. So I might try something, and you have something different. That doesn't mean what you have won't get you to the same answer. So unfortunately, this is kind of hard for me to tell you this is the way you do it, because there's different ways. But as I walked around, I should see every single person in here trying something. So 1 over cosine squared is secant squared. Maybe that's the only thing you tried is 1 over cosine squared is secant squared theta. And it's the only thing you tried. Maybe you didn't even try that. Some of you didn't do that, but that's okay. Because I know there were different ways of doing it. Or maybe 1 over cotangent squared is what? Tangent squared. So some of you had this written on your paper. Some of you did it in a different way. Some of you had this written on your paper. You left this one, right? Yeah. Some people, oh, no, I'm going to go there anyway. Some people left 1 over cosine squared. Oops. CO2. Cosine squared theta. And then made this one, or made this tangent, and then wrote sine squared theta over cosine squared theta. So I saw both of these around the room. Both of these are going to get you to the right answer. I'm going to use the second one. However, the first one's probably easier. I'm going to use the second one because that's what I saw the most of around the room. But the first one's probably easier. If I do 1 over cosine squared minus sine squared over cosine squared, we are trying to get this to one thing. And right now I'm subtracting two fractions. In order to subtract fractions, what do you have to have? Common denominator. Do we have a common denominator? So I can subtract 1 minus sine squared theta over the common denominator. And then I go and I look at my identities from yesterday. 1 minus sine squared theta is equal to something for my identities. 1 minus sine squared theta, here it is. 1 minus sine squared theta, we wrote that down yesterday, is what? Cosine squared theta. So now I have cosine squared theta over cosine squared theta. And if I have something over itself, what does that equal? I'm pretty sure that is 1. These cancel out and you get 1 for your answer. Now if you went with secant squared minus tangent squared, that is a Pythagorean identity, and that itself also equals 1. So you could have just been done after one step for that one. But I wanted to show you the fraction part. Okay, so number 10, I'm looking at this, and I'll help you work through number 10 to start. I'm looking at this, and I'm looking at secant theta minus cosine theta, and those are not squared. So that's not going to be one of those Pythagorean ones. But I also know that secant and cosine are related to each other. Secant and cosine are what? Reciprocals. And what happens if you multiply two reciprocals? Yeah. What happens if you, what? Yeah.
Okay. That's like 5 minutes. In like 5 minutes?
I don't know. We got like.
I'll just jump in with you.
Okay. Identity. You did a month and the two.
Have it pass up?
Have it half.
Yeah. Please? I'll start it off.
Go back to your class.
I'm just sitting.
I'm recording right now.
Probably won't use this one.
Okay.
Just have 20 views on this one.
He's the one that broke the chair, by the way.
You walk in when the sub was here, you just kind of stared and then walked right back.
I guess he's looking at you. Like, look.
Because he comes and steals my candy over there. Okay. So cosine multiplied by secant is multiplied by reciprocals. If you multiply reciprocals, let me just make up some reciprocals real fast. 3/4 multiplied by 4/3. What happens when you multiply reciprocals? What happens? You get 1. That's the definition of reciprocal. So when we multiply cosine theta and we're distributing, so this is what I'm doing. Cosine theta multiplied by 1 over cosine theta. Subtract cosine theta times cosine theta. Okay, I distributed the cosine theta. What happens when I take cosine and multiply by its reciprocal? I get 1 over here minus cosine squared theta. And 1 minus cosine squared theta is a thing. It's a Pythagorean identity. It's 1 minus cosine squared theta. We've done it like 4 times on this worksheet so far. It's sine squared theta. Okay, number 11, the A is just like theta. If it bothers you, just change it. Kind of bothers me. Number 11, cosine squared theta multiplied by secant squared theta minus 1. I look at this and I go, secant squared theta minus 1. Actually, cosine and secant, what do I know about those? They're reciprocal, so if I multiply them, what's going to happen? So I change secant into 1 over cosine squared. I multiply that by cosine squared. I also distribute cosine squared to 1. I get 1 minus cosine squared theta, which is what? Okay, that's the 5th time we've seen this on the same worksheet. So we're thinking about reciprocals. Number 12, we have multiplying 3 different things. Yeah. I will give you those. Like a chart. Yeah, I'll give those to you. Oh my God. But do you not know what cosine theta equals?
I do.
1 over.
Like, do you have all of them?
No. Well, I go with my reading ones. I know the first one, but I don't know them all. Because I always use them, like, on paper. Alright, so when you guys look at these, and we think about reciprocals, in order to multiply 3 things, you have to multiply 2 of them together and take that answer and multiply by the 3rd thing. So I'm going to multiply 2 of them together. The 2 that I'm going to choose are these 2. Because what does cosine multiplied by secant, what's that going to give me? Let's see. Secant is 1 over cosine multiplied by cosine. What's going to happen there? Oh my gosh, somebody. Yeah, well, it becomes 1. They're reciprocals. Okay, so once I multiply those together, now I have 2 to multiply. I have a product here. Don't answer it. Don't answer it. What am I going to do now? What am I going to do now?
Yeah. Like a little precious here. Thank you.
It's like a random person.
What do I do?
I'm that class, whatever he's doing.
You FOIL them?
Yeah.
So we get cosine x plus 1 minus cosine squared x minus cosine x, which the first and last terms will cancel each other out. So we have 1 minus cosine squared x. What is that? It's only the 6th time it's been on the same worksheet, sine squared x. So that you learn it. Different things, but we're learning.
Is it like the most common one, or is it just
Alright, number 13. This is you think and try something. I'm going to walk around, I'm going to look at your papers. I want to see something tried on your paper. Number 13, try something. I'm not sure, look at your identities. Try something. Try something. I didn't know you meant plug them. I'm lost on something here. Did you multiply sign? Oh, the next one you're next to your Try something. Try something. Wait, what's from Susan? Try anything. Try anything. Try something. Try something.
Wait, you're actually close.
Yeah. So that's not. But if it's wrong, that's not going to work.
Oh.
Yes. Yes. Yeah. Yeah. Should I show it? Might not have that. Okay, so we look at 1 minus cosine squared x. And 1 minus cosine squared x is sine squared x. We just saw that like 7 times now. So sine squared x is the same thing as sine x multiplied by sine x. Those cancel because I just factored them. I just unmultiplied them. I just factored them. So our answer with cosine x over sine x is cotangent x. Okay, number 14 is tricky, so I'm definitely working you through that one because that one's tricky. Do not put a headphone in. So number 14, the numerator tangent squared theta is one of the Pythagorean ones. If I look at the Pythagorean ones, tangent squared theta by itself would be equal to what? Secant squared theta minus 1. So that's what I'm going to do first, is rewrite this as secant squared theta minus 1 over secant theta plus 1, and then that has a plus 1 after it. Okay. Now the reason why I did that is because I cannot cancel unless I factor. So when I have like a plus sign or a minus sign, I cannot cancel numbers that are next to plus or minus signs. I would have to cancel a factor. So what I'm going to do now is I'm going to factor this numerator. And I'll factor it with not secants first. I'll just make x's. This would be something like x squared minus 1. And that is a difference of squares, where you would have 2 parentheses. You'd have an x and an x, and you'd have a minus 1 and a plus 1. So that when you foiled it back together, the outside minus 1x and plus 1x canceled out. That outside and inside cancel. Okay. So instead of x squared minus 1, how will I factor secant squared theta minus 1? So what signs am I going to have? plus minus. What's going to be after the plus minus? What's going to be before it? Secant theta. So I factor the top, and when I factor the top is exactly the same as the entire bottom. So since the top is factored, I can cancel out the entire factor with the entire denominator. So what is left is secant theta minus 1 and then plus 1. And if I minus 1 plus 1, then I just really have secant theta. Okay. Now the last one is another factoring question. And it is a difference of squares, but they're actually to the fourth power. But it is that same difference of squares kind where we're going to have 1 plus, 1 minus, and then you square root the stuff. So this one's going to be secant squared theta plus tangent squared theta. And this will be secant squared theta minus tangent squared theta. So when they're fourth powers, they are not Pythagorean identities. But when they are squareds, they could possibly be Pythagorean identities. So we go and we look at our Pythagorean identities. Is either of these, I'm telling you they're both not, but either of these Pythagorean identities when you look at them? If I put tangent and secant on the same side, I think I did that somewhere. No, that's minus. If I have 1 equals and I move the tangent over, I'll have secant squared theta minus tangent squared theta. Isn't that one of my parentheses I just had? The second parenthesis? So what does that second parenthesis equal? So really I just have the first parenthesis, which is secant squared theta plus tangent squared theta. Using that same identity, secant squared theta equals, using that same identity, secant squared theta equals 1 plus tangent squared theta. So I'm going to add them. So I'm going to say secant squared theta equals 1 plus tangent squared theta, and then I bring down my plus tangent squared theta. So these are common terms, these are like terms. If I have a tangent squared theta and I add another tangent squared theta, what do I have? I have 2. Right. So now I have 1 plus 2 tangent squared theta. And there's nothing else that we know to simplify that anymore. We will not be able to get that one down to one thing. Just heads up, that one will not go down to one thing. But there's one like that in your assignment, so I wanted to show it to you. The rest of them should go down to one thing. Yeah?
There's no way to know if it'll go down to one thing or not. We have to take the time.
Experience. So that's why I'm telling you right now, this one won't, because you don't have the experience that I do. So you have the rest of class to work on the rest of that assignment. Ask me questions if you started and you got stuck somewhere. Do the assignment. That is your homework if you don't